Hi, in this video we'll take a look at an app that lets you send data from an Arduino to an Android so you can plot, log, and manipulate data. Here are some examples of devices it'll work with. This is an Uno and this is a Nano. This app works with USB, so you'll need the correct adapter for your phone. And it also works with Bluetooth, so if you have something like an HC05 Bluetooth module, it'll work with that as well, and we'll get to that later. So let's connect it via USB. I'm going to use a USB extension cable to make this a little bit easier. And connect that. And let's open up the app. So once you plug it in, it'll prompt you to click the Connect USB button. And then you'll see your device in the list. Click OK. And it will automatically generate the labels as the data is coming in, because of the semicolons separating different data sets. The sketch that this is running will be there'll be a picture in the video, and maybe it'll be in the description as well. So now that we have the data coming in, we can change the names of the labels. We can call this sine 1, sine 2, these are all sine waves, sine 3, and we can call this pulse. And we can make a new data label so that we can add some operations. We'll call this FFT, and we'll do an FFT of, let's say, sine 2. So sine 2 is 1, 2, 3, 4, 5, the sixth incoming data. So we'll click the little toolbox icon, and we'll select the sixth data set, and we will add an operation, which will be the FFT. And we will keep the length at 128, although you could change it to one of these values if you need to. So now let's start plotting. Go over to the next tab, and we'll plot on the first graph. Let's do sine 1. And you can see it's coming in there. We can also plot sine 2. You see it's a lower frequency. We can plot less points, so it'll be less jumbled together. Let's do 50 points. So it's a little more spread out and easier to see. And we can also plot, third sine wave. Or we can add another plot and put the sine wave there. Or let's remove that. We'll do the pulse signal. So now we see the pulse signal coming in on the second plot. And we can also rename the plots, so we'll call that pulse. And we have the FFT of second sine wave, so we'll add that on a new plot. We'll plot FFT, and you can see there it's lower frequency. Let's change the length to 80 so we can see that better. So that should be the lower frequency, that slow sine wave. Let's do an FFT of, let's call it FFT2, and it'll be on the third sine wave. I think that's data 7. And we'll add FFT, and let's plot that on the same plot. And you can see there's a spike at a higher frequency. And of course there are many other operations you can do. You can multiply by a constant, you can combine data sets, You can smooth the signal, differentiate, a lot of cool stuff. So let's do a gauge. Sometimes it's good to you want to be able to just glance at a gauge and be able to tell what the value is for some parameter instead of looking at like a number or a graph. So you can either add a single large gauge or 2 gauges or any combination you want. We'll just stick with 1 for now. And let's add data 2, which is the first incoming data after time. And you can see we are already at the limit, so we'll have to extend the gauge limits. See, that should do it. Yeah, and you can see it's just increasing. It's just constantly increasing the value. But if this was something that we could do the sine wave. Let's do that. We'll do sine 2, and we'll make this, let's see, 2, and this will be minus 2. And we can say the units, let's say the units were miles per hour. And you can see it's going back and forth like a sine wave. So if you had this as a speedometer or something like that, and you had it mounted in a car or on a bicycle or on a motorcycle, you can see this is it's going to be very convenient. Let's do the last tab, which is logging. So we can log data. It'll make a text file with everything coming in. So just hit start, and you can see it tells you where the file is saved and what the file name is. And while it's running, you can't change anything here because that would make things inconsistent. So yeah, it's logging right now. Let's stop the logging and we can check out the file that it made. Go to File Manager, and we'll go to SerialDataLogger, and this should be the one we just made. And you can see there's all the data. You have the labels written over here so that you can separate them into different columns like in Excel, and then all the separated data would be under each label. And that's how you log with this app. So now that we did that, let's do Bluetooth. So I'll restart it just to show how it works. So let's see. For this, we'll just need 3 pins. On the HC05, we'll need VCC, ground, and RX. The VCC is the red wire, ground is black, and RX is white. So we'll connect the VCC to 5 volts. We'll connect the ground to ground. Whoops. And the white will go to, so the white goes to the RX on the HC05 and it goes to the TX on the Arduino. Now that that's set up, we will power this via a USB wall charger. So I've got an outlet here and just a phone wall charger with a USB. Plug that in, and you can see it lights up. Everything's powered up. So first, we'll need to go to Bluetooth, turn it on, and you'll need to pair the HC05 in the Bluetooth settings. Once it's paired, you can exit out of Bluetooth settings and go back to the app. And when you click Bluetooth, all of your paired devices will show up in this list. So you just find the HC05, click it, and everything happens the same way as it did with USB. All the data is coming in. We can plot data 5 and data 6 are the sine waves. Plot that. Data 6, data 7. We can change size. Let's do 40 this time. You can see that the sine waves are coming in. We can plot the pulses, and everything else works the same way as it did with USB. Yep. I hope you enjoyed this video. Thanks for watching.